Water is indispensable to life and also to natural dyeing. Quality of water is very important. Water may be either hard or soft. Hard water has dissolved minerals such as calcium and magnesium. Hard water makes it more difficult to lather soap. It may also lead to lime scale deposits in household pipes. Hardness in water is measured by the presence of minerals such as calcium carbonate. Soft water is water that has less than 60 milligrams of minerals per liter. Hard water has more than 120 milligrams per liter. Soft water is best for almost all natural dyes, with the exception of madder, weld, logwood, and Brazilwood. These dyes develop better in hard water. Where your water comes from will often determine its quality. It used to be that natural dyers considered rainwater best, although near industrial cities or coal-burning centers this may no longer be true. Regardless of your water source, a river, a well, or a tap, it is important to understand your water and know how to adjust it. For dyes that prefer hard water, calcium carbonate can be added in the form of finely ground chalk, or an antacid tablet such as Tums or Rolaids. Water that contains iron is difficult to use for natural dyeing, as it will not be possible to achieve clear, pure colors. With iron, colors will be saddened, that is, muted, and darker. If you suspect there are minerals in your water, you can usually get it tested, but if testing is not an option, you can run a small comparison study batch using distilled water. Do 2 small batches of dyeing in exactly the same way. For the first, use your local water. For the second, use distilled water. Make certain that everything, mordanting process, dyeing process, fiber type, and especially the pot, is exactly the same for both batches. I recommend testing a couple of colors. A yellow. If it develops a green tinge, this is evidence of iron. If cochineal goes gray, this could indicate calcium or iron. pH. pH is a logarithmic measure of how acidic or basic a solution is. The range of pH measurement is between 0 and 14, with 7 being neutral. Pure water should measure 7. In daily life, we are familiar with the characteristics of acids and bases through their mild forms. We know acids such as lemon juice and vinegar, and we know bases such as baking soda, ammonia, and soap. As dyers, we may also be familiar with strong bases like lye. The pH of our water will affect the final color of a natural dye. In fact, we often test pH with a paper that has been impregnated with natural dyes that change color when placed in an acidic or basic solution. Litmus paper, or pH paper, contains a mixture of natural dyes extracted from lichens. If our water changes the color of litmus paper, it makes sense that it might also change the color of our dye. pH is just as important for the life of dye plants as it is for the dyeing process. Each plant that manufactures color is affected by the pH of the soil while it is growing. This sensitivity may carry through to the dyeing stage. For example, madder, Rubia tinctorum, likes a slightly alkaline or chalky soil. When dyeing with the roots, the rich reds come out best in a slightly alkaline dye bath. At Meiwa, when we are precision dyeing or testing, we measure and take note of pH at every stage, from scouring to mordanting, to the tannin bath, to the dye bath, to the rinse water. In this way, we can understand and manipulate pH. We can see if pH is influencing a particular color, or what pH is needed to achieve the precise color we want. Here are some ways to manipulate color through pH. Cochineal can be shifted to orange with the addition of an acid, such as vinegar, and to a deep fuchsia with the addition of an alkaline, such as soda ash. For kutch, adding soda ash to the dye bath will deepen the color. An after rinse of calcium hydroxide will redden the color. Lower the pH of a Brazilwood dye bath and you will get an orange red, or raise the pH and you will get a blue-red or brilliant purple. Dramatic shifts in color can be seen by changing the pH of a logwood dye bath. Logwood develops best in slightly hard water. Adding finely ground chalk brightens the logwood color, especially if there's no calcium in the local water. We generally use mild acids and bases to alter pH when we're looking to modify the color. There are two factors in play when we modify the pH. The first is the strength of the acid or base, and the second is the quantity we add. For example, calcium carbonate is a very mild base. Even if we add quite a lot, we will not raise the pH of a dye bath very much. Lye, on the other hand, is a strong base. If we add even a little, we could create a drastic change in the pH of our dye bath. For bases, we recommend sodium carbonate, or soda ash, calcium carbonate, or chalk, calcium hydroxide, calx, potassium carbonate, also known as wood ash, or potash, and ammonia. For acids, we recommend a dilute acetic acid, also vinegar, citric acid or citric acid crystals or lemon juice, tartaric acid in the form of crystals. For the natural dyer, it is very handy to have pH paper or a pH meter when working with new recipes or developing recipes. A word about soap. Technically, soaps are made through the saponification process and are always alkaline with a pH between 8 and 10. However, the term soap is also used much more generally. For example, we recommend washing with a pH-neutral soap. Technically, these are detergents, formed through a different process than soaps. The essential point is that they should be pH-neutral in order not to affect natural dyes, and we always recommend liquid soap. This should give you a brief introduction to water, pH, acids and bases, and why they matter to the natural dyer. In the past, dyers and artisans had a deep knowledge of how color worked and how to change it, even if they did not have a modern scientific understanding of the process. It is remarkable to think of all the elements that go into creating natural color and how the dyer can learn to master these.